Mitesh? Mitesh, am I audible?
Yes, ma'am, audible.
If our chairs, session chairs are joined, so I think we can start. Dr. Mishra has joined.
Madam, I have joined.
Okay, thank you, sir.
Okay.
So I think we can start because this is the last session, and after that there is a valedictory session. So we should finish it on time. So, okay, just a minute. Yes. So, very good evening all. I am Dr. Sonal Yadav, Assistant Professor in the Department of Computer Science and Engineering at NIT Raipur. I warm welcome all the session chairs and participants. Now I would like to request Mr. Mitesh to introduce our session chairs to the participants. Mitesh.
A very good evening to all. On behalf of the Department of Computer Science and Engineering, NIT Raipur, and 4th International Conference of Machine Learning, Intelligence and Signal Processing, I welcome all the respected session chair and participants. Our first session chair is Dr. Nishchal Mishra. He is an associate professor in a School of Information Technology at RGPU Bhopal. He received his BE and MTech in Computer Science and Engineering degree in 2000 and 2004 respectively. In August 2005, he became lecturer in the Department of Computer Science and Engineering at SATI Engineering College, Vidisha. He was appointed as assistant professor in School of Information Technology, RGPV, Bhopal in August 2007. Dr. Nishchal earned his doctorate from RGPV, Bhopal in 2014. His work about multimedia data mining. He is the author and co-author of more than 60 papers in international referred journal and more than 15 conference contributions. He has delivered several invited talks and expert lecture. His research interests cover several aspects: data mining, image mining, big data, cybersecurity, and forensics. I welcome you, sir.
Thank you. Thank you,
sir. Our next session chair is Dr. Mukesh Kumar. He is currently working as an assistant professor at Department of Computer Science and Engineering, NIT Patna, India. He has completed doctorate degree in Computer Science and Engineering from NIT Rourkela during 2013 to 2016 in the area of big data and machine learning. Dr. Mukesh Kumar has published around 35 articles in various SCI journals and conferences, and also received in many journals like Elsewhere, Springer, and India Science, etc. I welcome you, sir.
Thank you of you.
Our last session chair, Dr. Sheetal Lord, she has not joined yet. So we can now further, ma'am.
Yes, we can proceed.
In this session, we have 5 participants. May I request to the all?
Just a minute, Mitesh.
Yes,
so this is share your PPT. Last slide of your PPT.
Yes, ma'am.
So this is session 30 on data analysis and prediction under the track data science and analytics. In this session, 5 papers shall be presented. Paper IDs are 135, 183, 339, 387, and 458. So I request all the participants, please stick with the time. You have 10 minutes for presentation and 2-3 minutes for question answers. Because this is the last session, so I request again to stick with the time. So I think we can start if paper ID 135 is present here.
Yes, ma'am.
So please share your slides and start your presentation.
It's saying that host disabled participant screen sharing.
Mitesh, you have to make him co-host.
Yes, ma'am. 1 second.
So I think one more session chair has joined, Dr. Priyanka Mishra. So I welcome Dr. Priyanka Mishra ma'am. And actually, we
Hello,
have,
ma'am.
hello. So we have started the session because this is the last session. So it will, we are in hurry to finish at 5.
Definitely, definitely.
Yes, ma'am. So Ashish, are you
Ma'am,
able to share
no.
the Dr. Deepak, are you here?
Ma'am,
So-
slightly technical problem, delay problem. Wait for 1 or 2 minutes.
Okay, okay. So you are not co-host? Let me check. Mitesh, you are host. I think you can make co-host.
Yes, Ashish, now you can share your slide.
I hope my screen is visible to everyone.
Yes.
So, hello everyone. I'm Ashish Papne, and I'm here to present my paper titled Efficient Prediction of Annual Yield from Stocks Using Deep Learning. We'll start by discussing the background of the study, followed by the literature reviewed, the problem statement we tried to solve using the proposed solution, the methods used to generate the results generated from our approach, and finally, the conclusion drawn from our study. As we all know, predicting the yield from stock is essential for current as well as future investors. It decides how much you will make or lose by making the investment. There are various financial and non-financial factors affecting market volatility, and the scope of the study is limited to financial factor, which is historical time series analysis. The statistical methods currently used by businesses are auto-regression, which is future-based, and the moving average method, which smoothens out the curve by creating a constantly updated average price. The ARMA model is a description of the process in form of 2 polynomials. One is for auto-regression and second for moving average. The ARIMA model is auto-regressive integrated moving average method, which generalizes an auto-regressive moving average model. There are various black box and differential equation based methods like Black-Scholes method and heuristic simulation methods like Monte Carlo simulations. The drawback of mathematical model is that they require mathematical and statistical knowledge for improved result, whereas the heuristic models require less prior knowledge but are time consuming and computationally expensive for large data. Apart from the heuristic black box models, advancements in deep learning architectures and the advent of extensive amount of data, several deep learning models like RNN, LSTMs, and other ensemble models are developed to make historic stock price prediction easier and more accurate. We reviewed latest model architectures with breakthrough deep learning advancements for financial market. The first model we considered was FinRL Fraud Racer, which is a successor to FinRL, a reinforcement learning library for market simulation. It requires 256 CPU cores and 320 GB of GPU, which is way too expensive for developing a web application and for making it available to common people. The second model considered was FinRL. This library simulates the financial market based on reinforcement learning techniques, but it also had high response time compared to the proposed model. Whereas various CNN and LSTM-based architectures were also reviewed as a part of this study, such as CNN LSTM model by Liu et al. And by Bao et al. The model which we propose in this study is StockDL, which is a hybrid CNN LSTM-based library, which takes 120 seconds to predict the annual yield using a single NVIDIA Titan GPU and 180 to 200 seconds to generate annual yield on using 10th generation Intel i5 CPU without any dedicated GPU. The problem with the existing mathematical models and statistical models, as I discussed before, was the requirement of existing mathematical and statistical concepts. And the possible solution of this is using a black box model with pre-tuned data to generate results to increase the accuracy when data is fed. The drawback of using black box model is the increased computational cost and the response time. There are various intuitive and confidence-based approaches like buy-hold method, in which the user basically buys the stocks when the prices are low and holds onto them with a hope that the prices will increase soon. These intuitive methods are uncertain and in the best case might lead to high profit, whereas in the worst case might even lead to bankruptcy. The drawback of non-optimized deep learning architecture was discussed previously, which includes high computational costs and high response time. Through this study, we present to you and the community a user-friendly Python library and a command line application along with a REST API for future stock price prediction web apps. We have reduced the response time to 120 seconds and reduced the GPU requirement from 2 NVIDIA Titan GPUs to a single NVIDIA Titan GPU. The response time on a hexa-core 10th generation Intel i5 10th generation CPU is 180 seconds. The response time is reduced to a few seconds when we use a pre-trained model. We have refrained from generating any new data set, and we have used the existing data set provided by Yahoo Finance API. The dynamic trading strategy, which we employ in StockDL, makes the model prone and free from any past stock and market crashes. We follow a 4-step pipeline to collect data, generate results. The first step is collecting the data from Yahoo Finance API. The data is collected for a window of 6 years before the current date of making the prediction. After generating the 6-year window, we convert the data to a monthly opening prices, which decides our in and out strategy. The data is finally scaled using min-max scaler and is split in the ratio of 7:3 for creating a new training and testing data set. The training data is finally fed to the model architecture, which is trained when the user makes a prediction. This reduces the chance of error due to unforeseen past events in the stock data. We cache the trained model to reduce the prediction time if the user wants to use a safe model. The output of the model is in the form of zeros and 1. 0 signifies that we'll be trading out of the market, and 1 signifies that we'll be trading in the market. Based on this strategy, the calculations are made in the model to predict the annual yield and net yield after any potential reductions. Thus, it provides the investor with a strategy to trade and expect his earnings from the trade. The study compares the traditional vanilla architecture with an improved LSTM CNN hybrid or ensemble model. The LSTM model comprises 2 LSTM layers, the first layer having 300 nodes and the second LSTM layer with 200 nodes. Each LSTM layer is followed by a dropout layer which drops out 50% of neurons after each training. This dropout layer helps us in preventing overfitting. The final layer of the network is a dense layer which returns 0 and 1, denoting our trading strategy. The model is trained for 400 epochs with 48 batches at a time. We have used ADAM optimizer with an adaptive learning rate. This prevents us from getting stuck into local minima. We have tested this against various regression-specific loss functions for the model. And finally, we have used mean squared error to evaluate the loss and reduce this eventually when we are training the model. While optimizing the vanilla architecture, we tried adding more LSTM layers and increasing the number of nodes in the existing architecture. This was increasing the complexity of the model and the response time. To overcome the addition of new LSTM layers, we developed a new strategy by adding 2 one-dimensional convolution layers with 32 filters and 2 kernels. This was followed by another convolution layer with 64 filters and 2 kernels. We have used rectified linear unit as activation function for both CNN layers. As CNNs are well known for feature extraction, these layers work well and with much less cost as compared to LSTM layers. The CNN layers are followed by 2 LSTM layers, one with 300 nodes and another with 200 nodes. Between 2 LSTM layers, we have added 50% dropout layer, which drops 50% neurons to reduce the overfitting. And finally, we have added dense layer for returning 0 and 1. The training strategy we used for the ensemble model is similar to vanilla LSTM model.
You have last 2 minutes remaining.
Yeah, sure. So we can stop the model around 200 epochs, but as we don't get much decrement, we have trained it for the 400 epochs with 48 batches at a time. The advantage of using LSTM CNN model is that it has improved efficiency without much response time and with better quality of predictions as CNN extracts the essential features and LSTM gets to analyze the time series data. These were the predictions made by the model, and these predictions are available in the form of JavaScript object notation for better utilization in web applications. This table shows the predicted annual yield by using the prediction strategies. The following plots were generated for Reliance Industries Limited and for HDFC Bank for the considered financial year. And these 2 plots are for Apple Incorporation and the stocks of Alphabet Incorporation. This study concludes that we can improve the efficiency of vanilla LSTM network by ensembling LSTM and CNN layers without much increase in the training and response time. In this study, we successfully compared the black box deep learning strategies with statistical models and proved that their accuracy can be efficient in predicting yield for stock market. Through this study, we provide to the community StockDL, a Python library for predicting annual yields by investing in a particular stock. I hope you all like the study and would be interested in knowing more about the project. These following studies were used to formulate and strengthen the proposed solution. So I would like to thank everyone for being attentive. Over to the audience for any questions. Also, this is the link of the demo if you would like to have a look at the project. Thank you.
Any query from the session chairs?
Can you
Okay,
talk about
so
the
can you please?
accuracy?
Yes, can you please?
Yes, ma'am. Continue.
Can you talk about accuracy?
So
The
while
model
train-
accuracy.
While training the model, we were focusing more on the loss functions, and we have 0.01% training loss as well as 0.04% of validation loss while training the model.
Tell me about the precision and all that. All the 4 parameters, F1 and all.
The F1 parameters were not considered as we were focusing more on the regression task rather than the classification.
And is there any comparison that you can show me with a traditional way of what of?
Sure, ma'am. So these are the prediction. The blue color shows the prediction, the possible plot of the buy hold strategy, which is intuitive based. The orange line shows the moving average strategy. The red line shows the proposed mixed model, which we have proposed in the study, the LSTM CNN based model. And the green line is for your vanilla LSTM model. So every model was predicting with a similar accuracy and with reduced cost and response time.
Go back one more slide.
Yeah, sure.
One more. What is the validation of all these tabulated data?
The validation of all this tabulated data was that like the predictions are made for 2021 year, and we have just gone back to the original data set and compared all these data. So it was approximately same.
So where is that slide where you have an actual comparison between these two?
Like the slide is
Statistics.
not added in the presentation due to time constraints. It is available in the paper documentation.
So can you spell out what are their accuracy and your accuracy?
If I have to speak about, just a minute. Okay. So this was a model loss. If I have to show about the trained model, we closed at 0.05 approximately for both training as well as testing, which
What is the
proves that
learning rate?
the learning rate was 0.01 and was adaptive with 0.25% if we get stuck in the local minima.
Okay.
Yes.
And why you required a dropout?
The dropout was required to reduce overfitting, as LSTMs, they tend to learn more than required, and they just try to replicate the original trends. Like if I have a
Overfitting
drop,
is there in a training or testing?
overfitting is in the training scenario.
In the training.
Yes, in training we get overfitting.
Okay. How much overfitting?
No, it was we didn't obtain any overfitting as in the model. We just added dropout layer just for a layer of extra security and for reducing any unwanted knowledge required by LSTMs.
But it will make your model complex more, no?
Adding
If
dropout
dropout
layers.
is not required, then why you have applied it?
So that in future, if there is any chance of getting our overfitting model, as we are using dynamically training strategy,
How your model will be identifying that yes, there is a need?
we'll be monitoring that in the backend.
How?
By we obtain all these curves, and if we see any scenarios of overfitting or underfitting, we'll be monitoring that and we'll be working on that accordingly.
Is there any other solution other than dropout?
Adding more data can be of more help. Like we are using 6-year trading strategy, 6 years data. We can increase that to around 12 years or 15 years and so on.
So that will be making your model safe from overfitting.
that will try to reduce the chances of overfitting in the model.
What are the other methods that are available?
We can reduce the model complexity as well. Like I am using 300 nodes as of now for LSTM. We can reduce that to 150 layers and 75 layers respectively. And subsequently, we can just change the number of filters in the CNN layers we have added in the model.
How much time it will take to do all these calculations? What is your data set right now?
My dataset currently is obtained from Yahoo Finance, which takes around 30 to 40 seconds by a simple API call. And the training scenario takes around 2 to 3 minutes on the normal GPU and CPU devices. It won't take much time as of now.
Okay. That's all from my side.
Thank you.
Okay, Ashish, only one question I will ask.
Sure, sir.
So what is the main reason for degradation of time?
The main reason for decreasing the response time was the idea of creating a web application. If we use a website, no one would prefer to stay on a website and wait for the result for 7 to 8 minutes. The main idea of developing a strategy with reduced time was to create a simple website which can provide the user with the predictions in just 2 to 3 minutes, which we have successfully achieved in the study.
Okay, but in earlier models, how they are means taking too much time, and
The
your
earlier
model is
model,
taking time.
so
What is
earlier,
the main difference?
Sure. So the model which we compared in this study were basically based on reinforcement learning, and they were simulating the entire stock market environment from trading to even the selling and everything involved. And for now, we have just considered only one aspect of the study, which is the historical time series data, whereas ignoring other factors of the environment, which can be your word of mouth and other political and other events which could be simulating the market as well. So for now, just considering on one feature at a time and nailing one problem at a time, we have tried to reduce the time significantly. And by removing the traditional LSTM layer for time series, we have added more CNN layers, which will be focusing more on the feature extraction part. So that's how we are achieving this.
It means that task is totally different for you and earlier models.
Sorry?
Your task is totally different from theirs.
Yes,
right?
exactly. Yes.
Okay. Okay. Thank you.
Thank you.
Okay, Ashish, can you please stop your sharing?
Sure. Thank you.
It is my humble request to the all session share and participants to be specific on a time, because at 5 p.m. Our validatory session will be started. So our next paper ID is 183, Mr. Yonse.
Can I play a video? I was recorded in 10 minutes. Thank you very much for that warm welcome. I would like to thank the organizing committee and all of the volunteers in the 4th International Conference on Machine Intelligence and Signal Processing organized by National Institute of Technology, Raipur, India. My name is Younes Aziz Bashiri, PhD student. My doctoral advisor is Isha Monsef, Laboratory of Innovation in Mathematics, Application and Information Technologies, Sultan Lstm University. I will present the paper entitled The Study of Effectiveness of
Clicking on refresh.
Hello? Hello?
Yes.
You can
carry
hear
on.
me?
Continue.
You can carry on.
Okay. Essay scoring in MOOCs. It's an opportune time to renew contact and discuss problem. The plan will be as follows: background, literature survey, problem description, methodology, result and discussion, and finally a conclusion. Today, e-learning has emerged as a key issue with application in every business, including supported training, lifetime learning modes, and support tools for all types of educational institutions. As a result of the COVID-19's impact, millions of applicants take online tests via MOOC platforms. And while scoring brief response is crucial to the process, it becomes difficult to grade them using human graders. Unfortunately, multiple choice quizzes are inadequate for measuring high-level learning that extend beyond the lower-level Bloom's taxonomy. As a result, developing and implementing a generic automated system for grading this response is crucial. Utilizing computers to evaluate and grade students' assignment, simplify and cut costs. We investigate an automated answer scoring technique that combines machine learning technique with automatic natural language processing to produce a fast, scalable, and accurate result. We divided major EAS approaches into three categories: regression model, classification models, and neural network models. The regression models failed to find cohesion and coherence from the essay because it's trained on bag of words feature. In processing data from input to output, the regression model are less complicated than neural network. Susan 2020 proposed a text mining approach for short answer gradient. First, they're comparing model answer with student response by calculating the distance between two sentences. By comparing the model answer with student response, they find the essay's completeness and provide feedback. Sadin 2019 proposed an XGBoost machine learning classifier to assess the essay. The algorithm trained on features like word count, pause, part of credit, and coherence in the article with sentence similarity percentage. Cohesion and coherence are considered for training, and they implemented k-fold cross-validation for a result. The average accuracy after specific validation is 68.12. Evaluation can take numerous shapes and forms, which may vary depending on the learning objectives and disciplinary setting, and the technology that is available to participants. Peer assessment is frequently distinguished using formative or summative approach. There are various components that must be included when putting together an essay assignment. A set of questions or prompts for students to respond to, a set of guidelines. The assessments use a single rubric to grade all the questions. There are review both assessments can be used in conjunction with other types of assessment, such as peer and staff evaluation and self-assessment as seen in the figure. There are 8 essay sets in this computation dataset. Each pair of essays was generated in response to a specific prompt. Selected writing range in length from 150 to 550 words on average. Some of the essays rely on secondary source while others do not. All essays were written by children in grade 7 through 10. All essays were graded by hand and scored twice. Each of the 8 datasets is distinct and its own way. The unpredictability is designed to push the capabilities of scoring engines to their limits. Table 1 summarizes the data essay were hand-scored on a variety of scales, depending on the prompt, with each essay receiving at least 2 scores. To train and evaluate the learning model for this research, essay set 1 to 3 were utilized. The model can recognize and scale the scale difference and generate the appropriate grade. The data had already been pre-processed by using the Stanford Natural Language Processing Group. Feature extraction. 11 open source libraries were used to build a total of 16 features. Heuristic characteristics. Numerous heuristic elements were produced that are likely to add to the quality of an essay. Several heuristic aspects include the following: word count, big word count, word with a length greater than 6. Average word length per essay, quotation mark count, character count, sentence count, and comma count. Grammatical and spelling feature. It is expected that a learner will make grammatical and spelling error. Grammar check created a large number of spelling and grammatical problems. Tag for part of speech POS account for most common POS tags. Was utilized to assess and determining the sentence structure. For example, a count of noun, verb, adjectives, and adverb for a specific essay using NLTK. additional characteristic. Additionally, crucial metrics such as incorrect word, domain word, the quantity of words that are relevant to the essay domain, punctuation, count, and word-to-sentence ratio were generated using LTK
So you have
WordNet
last 2
library.
minutes remaining.
Single feature Kaba. Following the generation. Sorry?
2 minutes remaining. You have 2 minutes remaining.
Okay. Weighted kappa, mean absolute error, Pearson correlation coefficients. The quadratic weighted kappa will find agreement between a human evaluation score and system evaluation score and produce value ranging from 0 to 1. We ran the model via skill-learned dummy regressor to determine whether the learned model outperformed a model that always guesses one answer. It received a kappa score of 0, suggesting that there was no agreement between the projected values and the grade assigned by a human grader. Linear regression using the concatenated vector of word-to-vec model and the heuristic feature, a linear regression model with 5-fold cross-validation was then trained after evaluating the model with the test vector. An average kappa score of 0.93 was obtained during cross-validation. The final model, which was constructed using the word-to-vec model, generated word vectors, and the heuristic feature performed remarkably well. The score increased by 0.26 points when compared to employing purely heuristic feature, which was the method taken by a large number of competitors during the competition. The final score of 0.93 outperformed the benchmark by a factor of 0.543, and the model outperformed the winning team's score, showing the utility of utilizing a word-to-vec model for NLP tasks. We were specifically looking for response to the following question. To begin, to what extent may machine learning be used to enhance current method of peer review grading? Second, will the model produced perform well in terms of accuracy? For this portion of the project, only essay sets 1, 2, and 3 were used. Adding the next 5 essay sets to the model should have no effect on its efficiency, as the essay in these 5 sets contain essays comparable to those in essay set 3, which were created by a single prompt. The heuristic qualities were developed by considering the broad characteristics of an effective essay. These characteristics should be applicable to any essay in any domain. Similarly, a huge corpus was used to train the word-to-vec model. This should verify that the model is applicable to any essay input domain on which it was trained. The deep learning approach is very popular at present. The deep learning algorithm provided a great result for this task. Thank you.
Any query from session chairs?
Have you done the validation?
Yes, excuse my English because I'm Moroccan, so my third language is English. So we speak
Tell me
Arabic
about
and French.
validation. Tell me about
Okay,
the
the validation is doing with 10% of the data.
What kind of essay that you have considered for what, for evaluation of what of your results?
We use the set 1, 2, and 3 that use narration and essay, and essay from the Kaggle competition. We have
Okay,
do it with the dummy.
So is
Yes.
there any specific input that you required, or you can use your methodology on any kind of essay?
Yes, because we use word2vec. This is a good initiative for doing the thing, because word2vec is containing a lot of progress in NLP. Linear regression also using concatenated vectors.
If the assignment is based, if the assignments are based upon some mathematical calculation and like that, then how do you find your method suitable for what, for evaluation of all such kind of assignments?
Yes, when it's combined with the Word-to-Vec and linear regression, we have a good accuracy. So an average kappa for 0.93. We use a cross validation for that.
No, I'm saying that what the accuracy in case of numerical, if numerical essays are there? Have you tested your accuracy?
Yes, we have tested in a MOOC in English. That is in the MOOC platform in Morocco.
English and the summary type of essays are okay, but I'm talking about some kind of numerical where you have to get up your results in terms of analytics.
Okay.
Okay from my side.
Any other query from session chairs?
No query from my side.
Okay, thank you.
Sir, can you please stop your sharing? Please stop your sharing. Next paper ID is 339. Dr. Shinoj.
Sir, I will share my screen. Sir, is the screen is visible, sir?
Yes, it is visible.
So good afternoon, everyone. Myself Shinoj from VSSC ISRO. In this work, a strategy is devised to detect the peaks in a launch vehicle simulation time series data, and a tool is developed for the automated detection of peaks using this strategy. On behalf of the other participant, I am presenting this paper. Coming to the next slide. So these are the contents of the presentation. First, a brief introduction, followed by some of the strategies available in the literature. Then description of the problem and the details of the methodology used, followed by some of the results obtained, then conclusion and the references. Moving to the next slide. So most of the data in our activities like mission design, analysis and validation data are in the form of a time series. So, and the duration may be 1 second or below that. Also, we may have to do the analysis for these kinds of data for every mission. So we try to automate the process for these kind of activities. To develop an algorithm, we have taken a simulation testable data, and these are some of the features of the testable. And normally for a mission, 2 times it will come with 20, on an average 20 cases. Most of the mission duration will be 100,000 seconds, and the mission analysis maybe 30 to 40 parameters also may be there. So first we start with the peaks. So peak is defined as a very narrow region of high values with a sharp fall point on either side. So in the literature, what we have seen is the desired features are basically should be simple, and algorithm also should be fast, and ability to handle the multiple behaviors, and a presence of trend, seasonality, noise. This will explain the next slide. And the minimum number of parameters to be tuned, and with a minimum intervention, user intervention. So approaches for peak detection, what we have seen is some of the literature they are using smoothing and fitting non-function, or matching available non-peak data, or slope sign change, or a P function also used. So pitfalls in what we have seen is if we have a large number of data points like what we have, so 1 or 2 points, if you take the complete mean and standard deviation, it may not be suitable to identify the peaks. So this approach we initially tried, then we go to the methodology what we have proposed now. So time series is basically, I will go to the definition. So basically it having a base level and trend. Trend means it is a positive or negative slope. Then seasonality. Seasonality is a distinct, it is a repeated or a cyclic regular pattern, or noise is a random behavior or events. So these are all depicted in this plot. So now we focus on the event, that is a sudden significant or behavior in the variation of the data. So what algorithm, what we proposed is, so if we take each point and if we apply, we are applying a peak detection function, and if the peak function is above a threshold, we consider it as a peak. So basically here we used two types of peak function. First one is the first we identify a particular point, focal point. Then from the left side and right side, k points will be considered, and the difference, and then it's maximum difference with average of the max values. That is the first function. And second function is the difference average of the average. So this is one of the typical plot. That is, this is our input, and we apply this transformation data on this data. Then we reduce to a data which we can analyze. So what we are doing is, in this transformed data, we are applying our method. So basically, we are adaptive threshold setting we are implementing. So first basic level is a constant threshold. That means any high threshold or whatever threshold value which is suitable for the data which we can apply, or threshold based on some statistics, either mean sigma or RMS or something like that. But here some more feasible thing what we find is the adaptive threshold. So here we are we made the data into segmentation wise, and the segmentation data we applied two methods. One is the divided average method, and the second one is the moving average method. In the divided average method, each segment will be predefined number will be there, and that number will be very significant. So based on analysis, we arrived at a predefined number, and in the predefined number we divide into different segments. And second one is each point we will consider, and the number of points from the left and right we will consider. So these two methods we applied on the transformed data. This is one of the typical statistics using the moving average method. So this is the original input data, and it's the mean and the standard deviation. Now this is one of the typical result what we obtained. So here this is the original data, we transform data and apply the two methods. So here after applying the method, we focus on the event, that is the peak. So this is this and these two are considered the identified as the peaks. So this behavior we are not bothering. So here peaks, this is a slow varying behavior. First level we focus on the peak. So here this is detected as peak. So in the result, to analyze the performance, we formed a contingency or confusion matrix. So that that will explain what is the sensitivity, what is the precision, and the combined effect, etc. So here TP means true positive, and that true positive means points which are correctly detected.
Your last 2 minutes remaining.
Yes, right. Then similarly, FP means a false positive, TN is a true negative, and FN is the false negative. So based on this, so we have two peak function and two methodology. So method one is peak function, first peak function applying on the divided average method. M2 is the first peak function applying the other method, and M2, M3 is followed like that. So as a conclusion, this is the performance analysis. So since in the definition here, F1 is a combined effect of precision and sensitivity. So we arrived at M2 method. M2 is nothing but the peak function where MAM, moving average method, is applied, is more accepted. So as a conclusion, so we developed a automatic detection tool used for a time series data. So here two methods we apply: divided average and moving average method. So an adaptive threshold setting is introduced after applying these two methods. So based on F1 score, we can arrive that which, since it is combined effect of position and sensitivity, we can arrive at the peak detection, peak transformation function S1 with the moving average shows better performance than the others. So these are the references what we used. Okay. So any questions?
No question from my side.
What is the application of finding the peaks?
Actually, we have in our mission analysis, we are dealing with so many data sets. So instead of visually finding or manually detecting, we focus. We are trying to automate the process. So automation is one of the application which we found in this method, using this method.
Mhm. So by finding it means you are removing outliers or inliers like that?
Yes. Peak is also considered as one of the outlier.
Okay.
Similarly, any
Okay,
other anomalies which we can find that also can be removed.
Okay, that's all from my side. Thank you.
Our next paper ID is 387, paper number 387, Mr. Google Ganesh.
So hi all, good evening all. I'm Gokul Ganesh from Tyagarajar College of Engineering. So this presentation is about HDD failure detection using machine learning with the cloud computing resource. So let's begin. Okay. The hard disk drives are essential for computers, which act as a computer's data center. The speed at which the data is transferred and the program loaded on the PC is totally depends on the hard disk. It is a more essential to predict the hard disk failure in prior to ensure the data integrity, availability, and business continuity. To do so, the machine learning based approaches are adapted to predict the HDD failure. This is achieved by use of backblaze hard drive statistic dataset. One of the major challenges observed with the dataset is class imbalance problem. Let's see how we address these issues on upcoming slides. So basically, we have taken these 5 papers as a core reference of our projects. So first one is a comparison of machine learning classifier for predicting the water main failure. So in this paper, the predictability has drastically diminished following cross validation. So the next paper is elevation predictive maintenance through the visualization tool. So in this paper, a new time series specification approach to interpreting machine learning models based on PCA reduction techniques. So main challenges in this paper was integrating the lame neighborhood generator into the IPCA method. So another method paper is a machine learning predictive maintenance. So in this paper, each algorithm has a good accuracy for diagnostic. The next one is a hybrid intelligent predictive. So in this paper, the categorization of accumulator state was precisely identified as the most challenging for 4 components evaluated. The final paper is a prediction of public procurement correction. And this is using a machine learning methods. Problem description. Over the last few decades, many studies have focused on the task of predicting hard disk failures. A threshold-based method was employed in the previous approaches. These, on the other hand, were only 3 to 10% accurate in forecasting drive failures. The failure prediction method examined current and historical data describing the system states, events, and processes. The machine learning, which enables the training of prediction model from time series data, evaluation of model performance, and deployment in a productive environment, is becoming a more widely utilized technology for failure prediction. So coming to the methodology, so we are using a backplace dataset. In that dataset, when the records of one class outnumber those of other, our classifier may become biased towards the prediction. To avoid this, we are using an oversampling approach of adaptive synthetic algorithm, which is usually called as ADASIN. The primary idea behind ADASIN is to use a weighted distribution for different minority class examples based on their learning difficulty, with a more synthetic data created and for more difficult minority class instance than for easier minority class examples. Um, the selection of attribute is a basic and important thing in uh, machine learning. The feature extraction is a process of selecting a collection of features from a variety of effective approaches to lower the dimension of feature space. With all indeed pre-processing step, the significant features are extracted based on the two different algorithms, namely PCA, principal component analysis, and another linear time discriminant analysis, LDA. The PCA reduces the noise by condensing large number of characteristics into a few main components. LDA is a method of determining a linear combination of attributes that distinguish two or more classes of objects and occurrence. The study explores the best features extraction algorithm by exploring the three different ML algorithms: logistic regression, decision tree, and random forest algorithm to predict the disk failure. The random forest classifies the disk failure more precisely by proving 92% accuracy, 86% of precision, 90% recall, and 88% F1 score. The further execution of the time of the algorithm is decreased with the help of cloud computing resources. The Apache Spark from 5 minutes to 193 milliseconds. Let's briefly see these results. In the data set, we have a 130 features and 11,000 samples. In that 11,000 samples, 586 samples represent the failure class, and the remaining 8 samples represent the normal class. So that application of, so we examined the ADASIN algorithm has overcome the class imbalance issues by which the minority class instance have been raised from 8 to 11,586 samples. So the result observed while using ADASIN, so the decreased accuracy but a well-balanced precision.
Sir, you have 2 minutes remaining.
Okay. But the increased accuracy, this proves that the model predicts both class at a balanced rate. So in our data set, nearly 130 features have been represented, but it does not mean that all the features will help in building the best model. So we are using a PC and LDA on the data set in the feature selection process. It is observed that in this data set, the performance of LDA is doing better in our data set. So we are using that LDA. Though the validation parameters prove that model build effectively predicts whether the hard disk failure has a chance of failure or not, but there occurs some limitation due to the time consumption taken by the algorithm during the process of fitting. So to reduce the time factor, the proposed reduction algorithm is executed in a Apache PySpark, which takes a less processing time due to the feature of in-memory computation. So we in PySpark provides a high processing speed, so it drastically reduced from 5 minutes to 194 milliseconds when executed in the Spark environment. So the reduction of time consumption will help in effective prediction of failure. Okay, let's conclude. In this study, a machine learning model is provided in this work to analyze the hard disk drive failure. The suggested method has solved the problem of target variable distribution imbalance, and a suited subset for feature has been chosen. In terms of evaluation measure, the model described here performed well. The model performance in terms of validation metrics will be improved in the future, while overhead will be decreased. Thank you. Any queries?
How do you check the accuracy of your model?
What, ma'am?
How do you check the accuracy of your model?
We used 3 algorithms, compare it on one another. So Random forest algorithm doing better in our
No,
data
no,
set.
I'm talking about the accuracy. When you claim something, how do you check that is it correct or how it is going?
So we get accuracy of 97% in our of algorithms.
How do you check this accuracy?
Based on the algorithms, we check that accuracy.
No, I'm not satisfied with your answer.
So we used
Yeah, no question.
Any other query from Sanjay?
No, not from my side.
Okay, our last paper ID is 458. Mr. Shirajan Patil.
Yes. Is my screen visible?
Yes, yes.
Hello everyone. Today I'm going to provide my paper on long short-term memory driven RNN for real-time stock monitoring and prediction. So the table of contents are introduction, literature survey, problem description, key contribution, novelty of work, methodology, result and discussion, conclusions and references. Background: a stock market has an extreme effect on today's economy. It has always been a tough job to invest in stock market. In a world where inflation increases at 3% per year, we must invest our money to guarantee a future. However, the market doesn't allow us to predict the future of the assets with high accuracy. With the successful development in technologies, machine learning helps us to predict the stock market. So long short-term memory is an artificial recurrent neural network architecture used in the field of deep learning. It can process not only single data points, but an entire sequences of data. The LSTM rectifies huge issue that RNN suffer from, that is short memory. Using a series of gates, each with its own RNN, the LSTM manages to keep, forget or ignore data points based on probabilistic model. After a prediction is made, it is fed back into the model to predict the next value in the sequence. With each prediction, some error is introduced into the model. To avoid exploding gradients, values are squashed via sigmoid and tanh activation functions prior to gate entrance and output. Literature survey: Mehnaz has looked at predicting the stock market with autoencoder LSTM based on the data from 2000 to 2019. They have looked at their data. The data is split into two groups and their mean and variance are calculated. The efficiency of their model is demonstrated by comparing the results of GAN AE-LSTM with that's it. Anshul Mittal predicted the stock market by applying sentimental analysis to machine learning algorithms, finding a correlation between public sentiment and market sentiment. Based on the dataset Dow Jones Industry, they have collected 479 million tweets, including name, timestamp, and tweet text. For this purpose, they have used Granger causality analysis to see if mood values from that algorithm can predict how the stocks will move. Results from the Granger causality show that calm and happy are the main factors that make DGIA values go up or down. Problem description: there are many ML algorithms to predict stock market, which are linear regression, sentimental analysis, RNN, forest, etc. But they have an error percentage of more than 20%. In this presentation, we will devise a model using LSTM RNN that will predict the stock prices with very less percentage of error. Key contribution, novelty of work: real-time stock monitoring and prediction using deep learning model, fine-tune LSTM with 3 layers and activation function of ReLU, visualize and compare the results of two different companies. Methodology: importing libraries, Pandas, TensorFlow, sklearn, Yahoo Finance, and Matplotlib using the data from start of 2010 to the end of 2021. The companies used for the prediction is Amazon and Microsoft. We must take one of the KPIs to predict the model. So we took the closing price using sklearn to scale the data between 0 to 1 and converting it into an array. Test data and train data have been divided into 75% and 25% respectively. To build our model, we are going to use Lstm neural network. We use mean squared error and Adam as an optimizer for training. The structure of the model is shown in a figure. It's approximately almost 6 lakh parameters in our model. We have used different epochs for training such as 25, 50, 75, 100, 200, and 500 and compare our data with predicted price and actual price. As you can see, initially the predicted price was not fitting properly to the actual price, but as our epochs increased, the model was fitting perfectly. But during 500, the model was overfitting. So, and accurately at about 100 to 200, our model was perfectly fitting. Based on our training results, our model perfectly fits the trained data at a specific epoch, that is 100 for Amazon and 200 for Microsoft. RMSE for a model is shown in the table. For Amazon, it's 0.38 train and 0.43 test. Microsoft is 0.39 and 0.45. Accuracy of a model for Amazon is 74.5 and 84.3. For Microsoft, it's 78.4 and 88.2. So comparison of our work with existing work. So as you can see, most of the people had an average of 70 to 75% accuracy, but our model has real-time stock monitoring prediction. Conclusions: our model results show that it works very well, so we can trust it. As we saw, the prices are very close to each other. If you meet the right conditions, it can be very accurate. There is much more information you need to understand the stock market and predict the prices. In future, we will take the mood, sentiments of the market and add them to a model when we work on this project again. They act in the market based on how the market feels. Economic growth models can also help us predict how the stock market will do. We want to see how the model compares to other machine learning algorithms. These are the references used. Thank you.
Any query from session chairs?
What is the error
Cheers.
rate in your model?
So the error rate is 0.38, ma'am, RMSE.
Okay, and what about the others?
Others had around 2 to 4%.
Any dropout or anything that you have used?
I have used a dropout, ma'am, because of overfitting, but that
Overfitting at what, training or testing?
Training, ma'am, training. As you can see, at final epochs, the model was completely overfitting.
Can you figure out what are the reasons?
It's because of less data and as the stock prices, they go up and down because of that due to fluctuations in the market.
Okay. Any standard metrics that you could figure out for secondary databases?
Sorry, ma'am. No, ma'am. No.
Okay, no more questions.
So during the preparation of your data set, what is the window size you have taken?
Window size is from 2010 to 2021. It is around 2,400 data points.
No. During these are the data points, and these are the time series data set. So what is the cyclic order? Means what is the cyclic time? Means at which cycle your data is repeating?
Standard.
Maybe daily basis or
On daily basis. It
Daily
updates.
basis.
Yeah, it updates every day.
So have you considered all these windows, or directly you have fed your data to your model?
I have directly fed the data to a model and a window
So
also, sir. Both.
means I mean to ask that. So how you have means considered that this is the problem of time series data?
Sir, this is because you have to predict the prices. That is why I've considered it as
Yes, but you have to consider na cyclic order, or you have to prepare the data accordingly so that your model will understand that.
a window,
Okay,
sir. A window.
okay, okay. From my side, thank you.
Thank you, sir and ma'am. On behalf of the NIT Raipur and organization committee of the conference, I thank you all for sparing valuable time as well as providing valuable insight to the authors. It is kindly requested to the session chair to fill the evaluation sheet so that the best paper awarded can be decided and finalized. May I request to the session chair and participant to turn on their camera please so that we can take a group photo or screenshot.
Is it okay now?
Okay. Thank you, sir, ma'am, and participant. Thank you so much. Thank you very much. And may I request all the participant and the session chairs to join the validatory session. It is started now.
Okay, thank you.
So
Okay, thank you.
Thank you, Sheetal ma'am. Thank you, Dr. Nishchal Mishra, and thank you, Mukesh sir.
Thank you, ma'am.
Please join the valedictory session. Thank
Yes,
you
yes, ma'am.
and bye.